guys, if you find this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, today we will be learning about domain, range and graph of Cosec X and Cosec inverse X. So Cosec X is 1 by sin X. Now let's take an unit circle where at 0 degree, pi by 2, pi and 3 pi by 2 coordinates are 1 0 0 1, minus 1 0 and 0 minus 1 respectively. Now at 0 degree, cosec 0 will be 1 over sin 0 and sin 0 is 0, so it will be 1 over 0, which is not defined. Now at pi, cosec pi is 1 over sin pi, where sin pi is 0, so 1 over 0 is not defined again. So at pi and 0 degree, this function cosec x is not defined. Similarly, it will not defined at 2 pi, 3 pi, 4 pi, 5 pi, 6 pi and so on. Now since function is not defined at these angles, so we will have asymptotes at these points. So let's first draw the asymptotes at 0 degree, pi, 2 pi and similarly on the other side at minus pi and minus 2 pi. Now at pi by 2, cosec pi by 2 is 1 over sin pi by 2, where sin pi by 2 is 1, so it will give us 1. And at 3 pi by 2, cosec 3 pi by 2 is 1 over sin 3 pi by 2. Sin 3 pi by 2 is minus 1, so we will get minus 1 here. So at pi by 2, cosec x is 1 and at 3 pi by 2 it is minus 1, and we already know that 1 and minus 1 are the range for sin x. So the range for cosec x will be opposite to this, so it will be less than minus 1 and greater than 1. So the graph of cosec x will be in this yellow region. So the domain of cosec x is any x other than 0, pi, 2 pi, 3 pi, 4 pi and so on. So domain is x belongs to real number, but it cannot be 0, pi, 2 pi and so on, or we can say that x cannot be n pi. Now before moving on, let's understand the concept of plus infinity and minus infinity. So for cosec x, in first quadrant, if x is approaching towards 0 or x is approaching towards pi by 2, then y will be approaching towards plus infinity because cosec x is positive in first quadrant. Now in second quadrant, if x is approaching towards pi by 2 or it is approaching towards pi, then y will be approaching towards plus infinity because cosec x in second quadrant is positive. In third quadrant, if x is approaching towards 3 pi by 2 or pi, y is approaching towards minus infinity because in third quadrant cosec x is negative. Similarly, in fourth quadrant, if x is approaching towards 0 or 2 pi, or it is approaching towards 3 pi by 2, then y will be approaching towards negative, because in fourth quadrant cosec x is negative. So at pi by 2, if x is approaching towards 0 or x is approaching towards pi, then fx will be approaching towards plus infinity, because in first and second quadrant cosec x is positive. Now from 3 pi by 2, if x is approaching towards 0 or 2 pi, or it is approaching towards pi, then fx will be approaching towards negative infinity, because in third and fourth quadrant cosec x is negative. So the range of the function cosec x is from minus infinity to minus 1 and then 1 to plus infinity. So the range is fx is less than or equal to minus 1 to fx is greater than or equal to 1, or minus infinity to minus 1 and then from 1 to plus infinity. So the range is minus infinity to minus 1 and then from 1 to plus infinity, that is 1 to plus infinity. So a graph will be in this yellow shaded area. Now from pi by 2, if x is approaching towards 0 or it is approaching towards pi, then fx is approaching towards plus infinity. So let's graph it. So at pi by 2, if x is moving towards pi or towards 0, in both cases fx is moving towards plus infinity. Now at 3 pi by 2, if x is approaching towards 0 or it is approaching towards pi, in both cases fx will approach towards negative infinity. So at 3 pi by 2, if x is approaching towards pi or it is approaching towards 2 pi, in both cases fx will be approaching towards minus infinity. So similarly we can plot for 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2 and so on. Now if we draw a curve between this empty space, then we will see that this is the graph of sin x, and the maximum and the minimum point of sin x is where we will get parabolic like shapes. So for the function fx is equal to cosec x, domain of this function is x cannot be equal to n pi, and the range is from minus infinity to minus 1 and then 1 to plus infinity. Now for this function to have an inverse, it must pass the horizontal line test, and the horizontal line here is intersecting at more than 1 point. So this function will not pass the horizontal line test until we reduce the domain of this function. So let's take its reduced domain as from minus pi by 2 to plus pi by 2 and try to do horizontal line test again, and we can see that this time it will pass the test. So from minus pi by 2 to plus pi by 2 is the reduced domain where cosec inverse x exists. And remember that 0 is not included here because at 0 function cosec x is not defined. So for the function f(x) is equals to cosec inverse x, domain will be the range of cosec x, that is minus infinity to minus 1, and then 1 to plus infinity. And the range of inverse function is always the reduced domain of original function. So the reduced domain of cosec x is minus pi by 2 to plus pi by 2. So the range of this inverse function will be from minus pi by 2 to plus pi by 2, excluding 0 here. So 0 is not included because at 0 this function is not defined. So the range is from minus pi by 2 to 0, and 0 is not included, and then from 0 to pi by 2. So for the function f(x) is equal cosec inverse x, domain is minus infinity to minus 1, and then from 1 to plus infinity. So it is minus infinity to minus 1, and then from 1 to plus infinity. And the range of this function is from minus pi by 2 to 0, and then 0 to pi by 2, where 0 is not included because it is not defined at 0, and we have asymptote at 0. So let's first draw asymptotes at 0 pi, 2 pi, and then minus pi, minus 2 pi. Now since the range of this inverse function is from minus pi by 2 to plus pi by 2, so this is the principal value, and the graph of this inverse function will be in this yellow area, and there will be no graph between minus 1 and 1. So at pi by 2, if y is approaching towards pi or 0, then x will approach towards plus infinity. Similarly, we can graph it for 3 pi by 2, minus pi by 2, minus 3 pi by 2, and so on. And as we can see here, between minus pi by 2 and pi by 2, this function will pass the horizontal line test. So this is how we graph cosec x and its inverse function. Now here's the quick trick to know if your inverse graph is correct or not. So take the original graph, rotate it 90-degree counterclockwise, and then flip it. And this is the graph of inverse function.